Hi, in this video we solve question number 12 of IIT JAM 2021 mathematics paper. We are given with a second order differential equation with initial conditions. There are 4 options out of which only one is the correct answer. The options are about the behavior of the solution to the differential equation. Now, first thing we can do is try to find the correct answer by eliminating the wrong answer with the help of an example. But as it turns out in this case, finding the correct answer with the help of an example is not obvious. So instead, we are going to solve this differential equation. Now, if you notice, the coefficients of this differential equation are continuous functions. And in general, solving such differential equations is a tricky business. But in this case, we are in luck because this is a special kind of differential equation that we will see in a moment. Now, let us rewrite the differential equation by multiplying the entire equation by 1 plus x. So what we get is this. Now we can see that the coefficients are polynomials whose degrees match with the order of the derivative of y. This is a special kind of differential equation. It is known as Euler's second order differential equation. And there is a nice trick to solve such differential equations. And the trick is substitute the polynomial 1 plus x as e power t, which makes sense because 1 plus x is given to be positive. If you do that, what do we get? Differentiate both sides by t, you get dx by dt equals e power t. Now, what does this give us? We have y prime x equals dy by dx. Now what we do is apply the chain rule. This is equal to dy by dt times dt by dx. Right. Now dt by dx is the reciprocal of dx by dt, which is e power minus t, and we get y prime x. Now similarly, what do we have? We have y double prime x. This can be written as d by dx of y prime x, right? And this is equal to d by dx of the value of y prime x, which is e power minus t times dy by dt. Now again, apply the chain rule here. We can write it as d by dt of this entire term times dt by dx. Now in the first term, we can apply the product rule of derivative. It turns out to be e power minus t times d2y by dt square minus e power minus t times dy by dt. Bracket close, and we know dt by dx is e power minus t. Right. Now this is equal to e power minus 2t times d2y by dt square minus dy by dt. Very good. Now that we have y prime x, y double prime x, we rewrite the differential equation by applying the substitution. And here's what we get. Let us recall the expression for the given differential equation. It is given by this 1 plus x, y prime x minus yx equals 0. Now with the substitution, by substituting 1 plus x as e power t and the expression of the y double prime and y prime x, we get the following expression, right? Now, plus 1 plus x is e power t here, and y prime x we have got as e power minus t dy by dt. And then minus y equals 0. Now, there are some cancellations right here. These exponential terms cancel, and what we get is this: d square y by dt square minus dy by dt plus dy by dt minus y equals 0. Now again some cancellations, and we get d square y by dt square, with these terms cancelling, minus y equals 0. Now this is an easy example of second order differential equation with constant coefficients. And there is a standard way to solve such differential equation. You consider the auxiliary equation depending on the form of the differential equation, which in this case is m square minus 1 equal to 0, which gives you m equals plus minus 1. And since the roots are distinct, the general solution is given by c1 times e power 1t plus c2 times e power minus 1t. Right. Now, obviously, we are going to resubstitute the value of 1 plus x as e power t so that we have our solution in terms of x. So this gives you y as a function of x equals c1 times 1 plus x plus c2 times 1 plus x power minus 1. Now, very good. Now let us apply the initial conditions so that we can find the values of c1 and c2. Y at 0 is 1 and y prime at 0 is 0. So let us substitute that here. We have y at 0 equals 1, which implies c1 times 1 plus c2 times 1 is equal to 1. And similarly, y prime 0 is equal to 0, which implies you first differentiate and then substitute x as 0. So first term derivative is 1, and the second term, if you just differentiate and substitute value at 0, you get this. This is equal to 0. And so this implies that c1 minus c2 is equal to 0. Now solve these two linear equations by adding and subtracting, and what we get is c1 equals c2 equals half. So we get the following solution to the differential equation. Now very good. Now let us examine the given options. Now option 1 says that y is bounded on 0 to infinity. So we have to check if our solution is bounded on 0 to infinity or not. Now we see that this is sum of two positive terms, and the first term blows up as you take x tending to infinity, right? 1 plus x goes to infinity. So clearly y is not bounded on 0 to infinity and a is not the correct answer. Now what about b? Is the solution bounded on minus 1, 0? Now again, the second term in this case blows up. It goes to infinity as you take x tending to minus 1 from right hand side. So again, B is the wrong answer. Now for option C, it is wrong obviously from the given initial condition. So C is not the correct answer, and hence D is the correct answer, and this gives us the solution.